Okay. So everyone has this outline. It's answering text-dependent questions. So I'm going to go through the outline with you and show you the strategies, what we're learning about today. So we want to get better at reading text-dependent questions and being able to read an article, understand it, and answer the questions effectively. So the very first thing that you want to do is you want to preview the article, all right? That means look for and read headings of the entire article, look at pictures and browse captions, look for bold-faced terms or larger print that stands out, make an inference based on the above items on what the article is about. So let's do that piece together. So everyone has their article. Let's take a look at it. So I'm going to start by looking at the title. Okay, so here's my title, From Stem Cell to Any Cell. All right, it looks like there's a quick little abstract here. The search is on for ways to use stem cells to treat injuries and cure diseases. I see that it's in 2005. The author doesn't mean much to me here, so it's a little outdated, right? It's not completely current. Looks like we have them broken up into chunks here. Here's a picture. This picture sort of looks familiar to me. It says these images show human embryonic stem cell colonies as grown in 1998. Embryonic, I don't know what that means, so I'm going to come back to that. On the back here is the end of the caption. Researchers at the University of Wisconsin-Madison in different stages of development. Okay, it looks like we got another bold-faced term here about living better. Flipping it over, I see another picture, and human embryonic cells can turn into a variety of different cell types, including the gut, neural cells, bone marrow cells, cartilage, muscle, and kidney cells. All right, so I've previewed the article. Who would like to make an inference about what the article is about based on what we just looked at? So, Brielle, what do you think?
Embryonic cells.
Okay, how many agree with Brielle that this probably has something to do with embryonic cells? Okay, and I need a piece of it. Anybody want to add to that, what they're inferring the article to be about? Snehal?
I think it's about like how one cell can turn any of the final cell.
Okay, so from your title and from what you're looking at in the captions, you're thinking that one certain cell might be able to turn into some other cells? All right, anybody agree with Snehal's inference there? All right, Bridget, what were you thinking?
I think it's about like the development of one cell to like grow, like how it's like an embryo inside of an fetus.
Okay, so maybe you have a little bit more background information on what those terms mean, so you're inferring some other things that some other people might not have done. All right, so that's going to happen, right? Some of us are going to have different prior knowledge on topics or certain terms, and we may be able to infer a little bit more than maybe some others. So it's really just trying to wrap our mind around what's this article going to be about. So just kind of gearing up for how we're going to be able to answer these questions. So we know it has something to do with stem cells and something to do with other cells. How many got that out of it based on what we just read? All right, good. So let's look at our second piece of the outline of what we should be doing. Now we want to preview the questions. It says to read through the questions before reading the article. Circle or underline key terms or phrases the questions are asking. Keep a mental note of these questions while reading. So your questions are on the back of this outline, so let's flip it over and let's read them together and see if we can underline or circle things that we think are important enough for us to make a note of. So first question is, what is a stem cell? Does anybody see anything important on here we should underline or circle that we think is worthwhile? Shannon? Okay, well, the one thing we want to be a little bit careful with is that we don't want to underline almost the entire question because it kind of defeats the purpose of underlining. So we want to stick to just quick key terms. So what things do we think stand out the most in that question that we're like, ooh, we're going to need to make a mental note of this while we're reading so that we can definitely pick up on what is a stem cell. So, go ahead, Shannon, you want to try? Definitely stem cell, right? We definitely were doing that. What else, Vin? Hey, what? Okay, so even though it's most of the question there, we're looking for what it is, right? So that's kind of our starting point. How about the question 2? It says, what are 2 possible uses for stem cells? Give specific examples from the text. Go ahead, Sarah.
Uses for stem cells?
Uses for stem cells, okay. Again, I'm not going to worry about underlining the word for because it's kind of like a silly word. So uses, stem cells, okay. What would be something else that we should? Elena? 2. I'm going to circle 2 because we don't want to forget when we start to answer this question. If we just answer it quickly, we might forget to write about a second one. We might only include 1, which is a mistake that I had noticed a lot of you making on the B articles, where you would answer part of the question, but not the whole thing. So making sure we get 2 in there. Is there anything else that we think is worthwhile underlining in that question? Justin? Specific what? Yes, specific examples. So we want to make sure we're giving specific examples and that we're not just doing this generic overview of what the uses are. Okay, good. And where are we getting those specific examples from? Luke? The text. So we want to make sure they're coming from that text. All right, where do stem cells come from? So what might be worthwhile underlining there? Taylor? Okay, where? And we know we're talking about stem cells at this point, so I might not bother underlining that. Some of you might want to, so we don't all have to do it the same way, but if it's helpful for you. Where and what are we looking for? Where what? Sneha? Where they come from. So we've got a what question, we've got uses, we need 2 of them, and we need a where are they coming from. All right. And then we've got use evidence from the text to support the statement on page 3. The goal of stem cell research is to help people live better. What do we think is worthwhile there? Michael? All right, we definitely need evidence. That's important to underline. What else? Vin? Say it again. Okay, again, evidence is coming from the text, so I'm not going to put from the, just text, because I know that's where it's going to come from. And what's something else that's important? Sarah? All right, we want to be able to support. Is statement going to be worthwhile to underline? No. Probably not, because it's just the word statement, right? So what could we maybe do instead? Carly? Yeah, page 3. I'm going to circle it because I want to be like, wait, where do I have to go for this statement, right? So knowing page 3 is where I have to refer back to. Do we think it's worthwhile to underline the statement itself? Probably not, because we're probably going to have to read it again, right, to find this exact statement on page 3. So knowing it's on page 3, I'm probably going to look back at the question and be like, wait, what was that statement? And find it on page 3 before we answer. All right, good job. So let's look at the next piece of the outline of what's expected for us to do. So at this point, we've now previewed the article, we've previewed the questions. The next piece of our outline is to annotate the article as you read. Who's heard of annotating before? Very good. Making your language arts teacher proud. Who's done annotating before? Yes, good. So, how many of you annotated on the B article? Barely anybody. I was crying as all those papers were going into the recycling bin with nothing written on them. I should have said, if you didn't write on them, put them in one pile. If you wrote on them, recycle them. There was hardly anyone who annotated. So that's what I mean by transferring your language arts skills to science. Don't just forget about them when you leave language arts. You need to start doing them here too. All right, so we're going to practice annotating. I'm actually going to model it for you on a good chunk of the article today, and then you're going to get a chance to annotate yourself and be able to answer some questions. All right, so let's see what are some good things to do when we annotate. These are things, again, that should be very familiar to you because you've done them. Underline key ideas. Make a comment about the idea. Possibly a number question that it pertains to. So maybe you have a really good memory and you remember what question went with what. Right? Circle words that you don't know the meaning. After finishing a few sentences surrounded by the word, try and use context clues to write down what it means. This is really important in science text because, like I said, you're going to come across a lot of words that are really funky, that you're not familiar with. So trying to use those context clues instead of just reading it to read it and having no idea what it means, okay? Because most likely those words that you don't understand are words that are going to help you understand what you have to answer about those questions. So you need to try to figure it out. Are you always going to be right? No. But at least you took a shot at trying to figure out what it was to help you understand the article better. All right. So we're going to do that in just a second. I'm going to show you my model of annotating. And then we're going to answer questions. So we're going to refer back to the text to answer questions. Typically, questions start from the information in the beginning of the article and follow the order of the text. The beginning of the text would be a good place to look for the answer to number 1, and the end of the text would be a good place to look for the answer to the last question. Is that always the case? No. But it's a good starting place, right? Because a lot of times the text is organized in that way and they have questions that follow it in order. But not always. But a good place to start to try it out. All right, so I'm going to now annotate the text for you. So I'm not going to really be asking your opinion for it right now because I'm just modeling it for you. So I'm going to literally just annotate as you kind of copy my annotations, and you're going to then get a chance to answer some questions using my annotations. Then you're going to get an opportunity to try it on your own. All right, so a chunk of the article I'm going to do with you. So we're going to read it together, and I'm going to show you what my thought process looks like as we do this. All right, we all ready? Got our article, pen in hand? Okay. All right, so I had already read the title. I started my annotations a little bit here. I got from stem cell to any cell. I already noted that the date is outdated, and my little abstract here, it says the search is on for ways to use stem cells to treat injuries and cure diseases. All right. So for maybe a day, about 9 months before you were born, you were just one cell, then you were 2 identical cells, then you were 4, then you were 8. Huh, so this looks familiar to me. 1 cell, then 2 identical cells, 4, then 8. Looks like here we're talking about cell division. We were just learning about this, so I'm going to write that down because I think that's what they're talking about. All right, since then, you've grown into a complicated organism with many trillions of cells grouped into specialized tissues and organs. The cells in your brain do the thinking, the cells in your heart pump blood, and the cells in your tongue let you taste food, and so on. All right, so looks like I'm a complicated organism, lots of cells now. So it looks like I have specialized tissues. So I have certain cells in my brain that think, cells in my heart that pump blood, and cells in my tongue that taste food. Okay, so it basically is just saying that, you know, certain cells do different things. Okay, so in recent years, scientists have made an amazing discovery. Even though most cells have specific jobs, some primitive cells, called stem cells, exist in everyone's body. Stem cells are unspecialized cells that can develop into nearly any type of body cell. So there's some words in here that I'm not really sure of. Unspecialized, I guess it would kind of mean unspecialized. I guess it's the opposite of specialized that I saw here. All right, and primitive, I'm not sure. I've heard of that before. I think that might mean like early cells. I'm not sure though. All right, so even though most cells have specific jobs, some primitive cells called stem cells exist in everyone's body. Stem cells are unspecialized and can develop into nearly any type of body cell. So it looks like stem cells can be other cells. All right, so here it says stem cells are unspecialized cells that can develop. Oh, I remember that was actually number 1, wasn't that? Like they were asking, what are stem cells? So I'm going to make sure I come back to this when I answer that question. All right. So here I have that picture I saw before. Okay, now I understand. These are cells. I've seen this before. And it says these show human embryonic stem cells. So I'm still not sure what that word means. It's grown in 1998. Maybe I'll find it in another part of the article. Researchers at the University of Wisconsin-Madison, and they're in all different stages of development. Okay, so just cells in different development there. All right, embryos. Oh, embryos that sounds a lot like embryonic, what I just saw in that caption, so that's probably what that is. So embryos, babies in the earliest stages of growth before they're born, have stem cells. Certain tissues in adults also contain stem cells, although the range of cells into which they can develop is limited. Alright, so embryos they must be babies in earliest stages of growth before they're born. So now I guess that's probably what they were talking about with embryonic stem cells. So looks like here they're talking about that the stem cells can be in those embryos, and then tissues in adults also have some of these stem cells. So I think that was one of my questions before, right? Of what they come from. So I'm just going to write that on the side. I'm pretty sure, but maybe not. So in 1998, scientists at the University of Wisconsin-Madison figured out how to collect human embryonic cells and make them grow. Since then, researchers have learned to mix stem cells with combinations of proteins called growth factors to make cells grow into different types of cells. Now the search is on for ways to use stem cells to treat injuries and cure diseases. Whoa, that's like an overload of stuff. I don't really know what this paragraph's saying, so I'm going to go back to that again. So, wait, they figured out how to collect. Okay, so they're collecting human embryonic stem cells. Okay, and there's that embryonic. I'm just going to write babies because that's where I saw that. Okay, so they're collecting these baby stem cells and they're making them grow. And they're mixing these stem cells with proteins that are like growth factors, and that's making them grow into different types of cells. So they might be using them to treat injuries and cure diseases. Okay, so I think they're just saying that these stem cells can be made into other types of cells. Alright, so for example, stem cells could be extracted, turned into new bone cells, and then injected into weak or broken bones. Or they could become nerve cells that could heal spinal cord injuries, skin cells that could replace badly burnt skin, or brain cells that could help people who have suffered brain damage. The possibilities are endless. So that's quite a few things they could do. New bone cells for broken bones, nerve cells for healing spinal cord injuries, skin cells for badly burnt skin, brain cells for brain damage. So a lot of endless possibilities here. So I think that was one of my questions, something about like how they help people. So I'm just going to write that on the side here, how they help people. And at this point, the ability to create all the different cells in the body has been pretty much proven to be real, says Gary Friedman. He's the director of Center of Regenerative Medicine in Morristown, New Jersey. All the focus now is on getting new cells to behave the way we want them to and go where we want them to go. So it sounds like they have the ability to create all cells in the body, but it looks like from this last quote here that there's still some research that needs to be done, and that maybe they don't have it all figured out. Okay. So that was my model of what annotating could look like in a science text. So what I want you to do now is, using my annotation, you're going to try answering the first 3 questions. Okay? So when you finish those 3 questions, then you can go on to read the last portion of the article using your own annotations, and then you can answer number 4. So start with just answering the first 3 questions, then you can annotate the rest of it and answer 4. All right? So go back to my notes and try and use that as a guide to answer those text-dependent questions.